To begin Chapter 4, we're going to talk about midsegments and bisectors. A midsegment is a segment connecting the midpoints of two sides of a triangle. And we know those are the midpoints based on the markings of the triangle. The theorem related to the midsegment says that if a segment joins the midpoints of two sides of a triangle, so if a segment is the midsegment, then the segment is parallel to the third side and half as long. So this theorem gives us two pieces of information. First, if we have a midsegment, we know that that segment is going to be parallel to the side that it doesn't touch, and it's also going to be half the length of that side. So let's look at a couple examples. Name three pairs of parallel sides. Well, we know that we have three midsegments inside my triangle, and we know midsegments are parallel. So if we look at our sides, we have AB is parallel to FE, side BC is parallel to FD, and CA is parallel to DE. To find the measure of angle 1, we again know we have a midsegment. And because it's a midsegment, we know it is parallel to the third side of that triangle. And so now I have two parallel lines cut by transversal, making these two angles 1 and 55 corresponding angles. And corresponding angles are congruent. So angle 1 is 55. Find the length of DC. Well, again, DC is a midsegment because D divides XZ in half and C divides XY in half. So D is going to be half of ZY, which is making DC 9. It's your turn. Try these three. So our parallel sides, X, Y, and M, Y are parallel, YZ and NL are parallel, and ZX and ML are also parallel. Given our information, we know TB is going to be half of QR because it's the midsegment. And so QR is going to be 60. UT is going to be half of RS, making UT 20. And UB is half of QS, making UB 25. For the next one, we know AD is 6, so DC is the same length, it's also 6, making AC 12. EF is half of AC because it's a midsegment, and so EF is 6. And DE is going to be half of AB, and DE will be, or AB then, is going to be twice as big, which makes AB 15. A couple more definitions we need to talk about. Equidistant, a point is equidistant from two objects if it is the same distance from both. And distance from a point to a line, if we're going to find the distance from this point in red to the line at the bottom in blue, we're going to do that by drawing a perpendicular line to it. That's going to be the shortest distance. If I drew diagonally, I'm not going to have the shortest distance. So the shortest distance from a point to a line is a straight line that is perpendicular. Couple theorems we need to know. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, it is equidistant from the endpoints. So I have a point on the perpendicular bisector, so I know that point is the same distance from the endpoints of the segment. The converse is always true. That says if a point is equidistant from the endpoints, it is on the perpendicular bisector. So we know that this point is on the perpendicular bisector. Angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant from the sides. And this is where we're talking about distance from a point to a side or to a segment. It's going to be a straight line 90 degrees. And the converse is also true, that if a point is equidistant from the sides of an angle, then it is on the angle bisector. So I know those angles are congruent. Let's look at two examples that have to do with this. So we want to find the length of AB. Well, BD is the perpendicular bisector of AC. So point B is going to be equal distance or equidistant from point A as it is from point C. So we can set 4x equal to 6x minus 10 and solve. X is 5. We plug that back in. We get AB is 20. And RM, well, R is on the angle bisector of the angle MNP. So it is the same length from NM as it is from NP. So 7x and 2x plus 25 are equal. And when we plug that in, RM is going to be 35. Now it's your turn. Try the examples and pause the video and come back when you're ready. So again, I know that PQ and QR are going to be congruent. So I solve for N and plug it back in and get QR is 8. And the measure of ABD is going to be congruent to DBC because I know those angles are bisected based on the distance. So I can set those equal to each other and I get X is 15. And when I plug it in, ABD is 93. And that's it. We will see you in class. Bring your questions to class.